Hello. Testing web apps is very, very easy, said absolutely no one ever. And the reason why people are not saying this is because the modern web has evolved from being a series of links and articles to the wonderful experience that we have today in the browser. To give you an example, the James Webb Space Telescope that captures never before seen images of the universe, its UI is built using JavaScript. And another example is the SpaceX Crew Dragon that takes astronauts from Earth to the International Space Station, has a control system that is run on Chromium and JavaScript. So the browser today is not just what we know before, but it actually has transpounded to something else entirely. And let me tell you a story. So right now I am part of Glovo, which is a delivery company. It was founded 8 years ago in Barcelona, and it operates in 25 countries. Tech-wise, we have an app for couriers, for partners, back office, and customer application. Zooming in on the customer applications, we have an iOS, an Android app, and of course, a web application. All three of them use the same API, and they have in total around 20 million orders. And what's unique about this company is that it has absolutely no QA. And for me, this was a really big thing, because I came from a company before that had 2 or 3 dedicated quality assurance engineers inside the team, which would test your application, write a test for it, and then approve it once it reaches production. So I went from a company that was with a lot of quality assurance to a company that had 0. And when I joined this company, I asked my buddy who was in charge of my onboarding, hey, how are we going to do this? How is the workflow inside the company? And they said, hey, you're just going to have to follow the old testing pyramid. You're going to write a lot of unit tests. You're going to write a couple of end-to-end tests. And then once the feature is ready, you just have to manually test your feature. And I was like, manually test my feature? This isn't something that usually us developers like to do. It's like, we're lazy. We don't have that attention for detail that is usually expected from a quality assurance person. But I didn't want to ruffle any boats, so I did it. I took my first feature. I wrote some unit tests. I wrote an end-to-end test. And then I manually tested my feature, of course, like we're supposed to do. And of course, what happened is I broke the CSS of almost all the dialogues in the application. But rest assured, the feature that I was working on was perfect. So job well done, in my point of view. And what's funny is that at the time, we didn't have continuous integration, and we had to release every 2 weeks. We were doing a release train every 2 weeks. So when this happened, my bug had to stay in production for 2 weeks. Every time in the hallway, I was ashamed of looking people in the eye. Everybody knew what was happening. But yeah, funny stuff. So, and for this, we found out that the old school testing pyramid was not as useful as we assumed, right? It was comparing speed. It was saying, hey, it's faster to write unit tests than to write end-to-end tests. It was comparing costs. For example, it was saying that writing unit tests is cheaper than writing end-to-end tests. And it was not comparing confidence. Like, you are not confident that all of your unit tests were passing. That means that everything is working correctly. While if your end-to-end tests were passing, you at least knew that your business metrics were going fine. So there are a lot of variations of the testing pyramid out there, like the testing cup or the testing obelix. And I decided, to make my own for this talk, especially because all of these testing structure are cool. So I wanted to have my own cool testing structure. So here it is, the testing wormhole. And what makes it unique for the other testing structures is, as you know, a wormhole is in space, so it has no up, down, right, left. So every part of the testing wormhole is as important as the other part. And the other feature is that it's in space, so no one can hear you scream your frustrations because your end-to-end tests are not passing. And besides that, I'm going to talk about 3 types of tests. So we're going to talk about lazy tests, unit tests on steroids, and feature tests for the front end. And the first part, of course, is going to be the lazy test. And when I mention lazy, I mean that you code it and then forget about it. You don't have to maintain them. You don't have to add anything to them as new features appear. So a good example for this is how you automate your commits. So we're using a library called Husky. It's an open source library that every time you push a little bit of code, it can run any scripts that you have in your pipeline. So for example, for us, we have a lot of ESLint rules that make sure that all our teams are following the best practices. We have rules for file structure, for file naming. We have rules for accessibility, and a lot of prettier that makes the code look better. And this is very important to us, and we have it as soon as you commit a message, we run the ESLint rules to make sure everything is working fine. Another example that for lazy test is like performance tests. As we know, performance really matters. There are 3 types of metrics that we measure that Google pays attention to, and that's our LCP, FID, and CLS, largest contentful paint, first input delay, and cumulative layout shift. And there's a clear correlation between CVR and performance, conversion rate and performance. There are a lot of research done on this, but it makes sense, right? If the application is faster, users are going to interact with it more and probably buy more from your app. And to measure this, we have all sorts of tools. We have Lighthouse, Web Page Test, Google Search Console, the Crux report, and a lot of RUM tools like Datadog, Sentry, etc. But for us, we found out that the most important are Web Page Test and Google Search Console. Why? So as we know, Lighthouse, we use it as developers pretty often, but it's not that useful once you go in on the problems. It's like the name implies, it's supposed to guide you to a solution, but it doesn't give you clear advice on what you have to do. But if you set up a Lighthouse library, it has it's called Lighthouse CI. It's developed by core members from Google, and you can integrate this into your pipeline to make sure that some tests are working as intended. You don't want any feature that you're adding to add some faults to your website, because then it's going to take you very long time to figure out what happens. So this, you can add it as a GitHub action hook. It has different types of levels. As you're familiar, maybe you're not that familiar with CI, maybe you're not that familiar with performance. So it has different levels that you can integrate into your application. And it looks sort of like this. You have in your pipeline, it checks for performance, for accessibility, exactly like Lighthouse is doing. And it can break your PR if it is not up to the threshold that you set. And writing it is very easy. All you have to do is in the second line, you have ci.lighthouse, and you give it a threshold and some configs like check for desktop, check for mobile, and so forth. And of course, size matters. So especially in the JavaScript world, you don't want your bundle size to be mega and mega of space. That will take the user so much time to download. And in today's world, people are browsing in metros, in countries with poor internet connection. So what you want is to make sure that a feature does not increase the bundle size of your application by more than some thresholds. So we're using a library called BundleLemon. It's basically a wrapper around bundle size. What it does is it looks for your bundle and checks, of course, if it has increased by 200K, then it's going to break your PR. But it adds an extra layer that it checks percentage-wise. Because when you're working in a very dynamic environment, in a big applications, you're always going to have code added, code removed, code added, code removed. So just checking for the max size, it's not enough. You want to make sure that a feature does not increase percentage-wise in comparison with the master branch. So in conclusions, keep your bundle small, use linter rules to enforce best practices. An increase in performance can significantly affect your CVR, so make sure you have performance tests in place. And Google is your friend. You have the Google Search Console and Crux report to verify your performance on a weekly basis. And use run tools like Datadog and Sentry to measure everything. Observability is key in this day and age, and we want to make sure that everything is measured. So unit tests on steroids. Unit tests normally are in the old school pyramid, like at the bottom, the most important. You can write, it's recommended to write as many as possible to make sure your application is tight. So what is a unit test? Of course, it's supposed to be testing the smallest unit of code in your application. And usually these are functions or pure functions. To give you an example, here is a sum function that takes two parameters, a and b, and returns the output of the sum of these two numbers. Writing a small unit of test is you import the sum function, and then you calculate the result, and you want to expect the result to equal 2. So this is like a normal test. Then you're going to test a boundary situation. Let's say, for example, you're going to give it, instead of positive numbers, negative numbers, and make sure that the expected result is correct. And then you're going to try to test some error cases. Like, for example, instead of giving it numbers, you're going to give it string. So let's do the sum by a T-Rex and a shark. And normally you would expect an error, but here it is not implemented. So in theory, this is very good for utility functions, mutations, helpers, API responses. But for us in JavaScript, and especially in Vue, 90% of our applications are components. And this is how a normal file would look like. You would have a setup, then you would have some props, you're going to have some functions, and then you're going to have the HTML where we're going to render everything and show what's happening. So what are you going to test here? So as you can see, the best thing to do is to look at your component and ask, does this part actually need to be connected to the document in any way? Or is it a separate unit system that can be tested in isolation? So look at it at the increment function that we have. We can very easily extract this into a different helper file, which transform it into a pure function. So you have your increment, it takes the current and the max, and you want to make sure that the current is not above the max, and then you increment it. And writing unit tests for this is very easy. Again, you just import the function, and then you run it to multiple test cases. But one question you should ask yourself is, who is watching the watchers? So you've wrote millions of unit tests. Your application is like 7 years old. You have so many unit tests that it takes you minutes, half an hour to run them. But are your unit tests useful? Are they doing what they're supposed to be doing? So for example, given our sum function that takes a plus b, what if by mistake you're just instead of returning the sum, you're returning 2. And then your unit test checks for the value 2, and wow, it's green. But this is not what you're expected. So this is a new concept, not actually new, it's been for a lot of years, but it's becoming popular again, and it's called mutation testing. So mutation testing, instead of testing the result, it tests that your function is failing as expected. So to give you an example, you have a function, and inside of it, it has some logic, some plus, minus, it does something with the parameters. And then the mutation library is going to take your function and just change it a little bit. It's going to turn that plus into a minus, for example. And then it's going to run the test. If it passes, that means that your function, your unit tests are not proper, because with one change, it's supposed to fail. And then it's going to take that function again and mutate it again. And again, until your function becomes unrecognizable. And then it's supposed to fail everything. And of course, if it's not failing, that means your unit tests are not good. You're going to have a report for every unit test that didn't fail, and you're supposed to take a look at it. To go into our sum example, then we are expecting the value 2. It's going to mutate it to be a minus b instead of plus, and then the function is going to fail as expected because the result is not going to be equal to. Then the mutation is killed and it goes forward with another unit test. So apply these practices to increase confidence. Mutations should be asynchronous. As you can imagine, mutating every piece of code and then compiling it, it's going to take a lot of time. So we usually set up these to run once every month, and then we have a report on which unit test is good and which is not. Separate logic from the UI, test results and not implementation, and keep the test compact and readable. If it's difficult to set up your tests, maybe rethink the design. And now you have your unit tests. They're good. They're doing what they're supposed to be. All of them are green. But this doesn't mean that this is how the user is supposed to interact with your application. We're just checking numbers and pure functions. That doesn't mean that the way the functions interact with each other, it's how the user interacts with your code. So let's get to the last point, which is feature tests for the front end. And feature tests usually are part of the upper bracket of the old testing pyramid. You were supposed to write them as you consider because they take a long time to run. But in today's modern pipeline, these can be faster than unit tests. A good example of feature tests are visual testing. So to give you an example, before, when you wrote an end-to-end test, you had to write, like on the left, all sorts of assertions and code to make sure that it checks everything. But with visual test, what it does is you have just one command, and that's it. Go to that page and check if it's correct. And what it does is it takes a picture of your actual browser page, and then it compares with what it had before in the master branch. And if there are differences, it's going to tell you, hey, something changed visually. Should we, is this change correct or is it not? If it's not, it's going to break the pipeline. So it needs a little bit of human interaction to verify the changes, but it's very good for catching changes that you do. For example, here, it's going to tell you that some placeholder is missing, some icons are missing. Obviously, these are not intentional, but it's going to tell you and pause the pipeline before you make a decision. And it's going to show you what is changed if you can hover at it. And this is used in all sorts of libraries like API tools or Storybook. You can integrate it with multiple libraries. And once you have this, new joiners will not break all the dialogues in the application because these tests are going to catch it. So thanks for that. Another good testing practice is component testing. So like we had our component before that was a counter. So it was rendering just this, the value of the count and two buttons with increase and decrease values. So what you want to test, like I said before, is the result and not the implementation. So what you care about is that count, that it goes up when you increase and it goes down when you decrease. And writing this in a component testing environment is good in multiple ways. One is because you can actually see what's happening. It's not run in a terminal. You can see it in the browser. Another part is you can trigger you can access the buttons by accessibility values like data or area labels. So you're going to interact with it like a user would interact with it. And then you can mount it with all sorts of props and test it in isolation outside of your app. When you have a big application with millions of components, you don't want to boot up your application just for one component. So here you can develop and test it in isolation using component testing. And testing it is very simple. You just get the value, you click it, and then you check if the result is what it's supposed to be. Very similar to unit tests or end-to-end tests. So you're using a real browser, you can see what exactly is rendered, and it's good for development environment. But most importantly, you're testing like a user. So speaking about real users, the last part would be end-to-end testing. And before we were saying that they are the most costly because they take so much to go through pages. Writing many of them will bloat your pipeline. They're very flaky because they depend on API responses. So normally the general consensus is they are slow. They have to wait for API response, they're very flaky, and a lot of duplicated tests. So how we did to solve this is by mocking absolutely everything, which is not a really good idea, but if you have contract testing in place, it will make your job so much easier. So this is what we did. We mocked the API completely. We have our own server that boots up and mocks and gives response JSON. We have contract testing in place to make sure that the API does not change. We run our end-to-end tests in parallel in the pipeline to make them fast as possible. And we implemented skip and mock functionalities to make sure that we are not retesting everything over and over again. So this is what we do. When we mock the API, when we boot the application, we have a mock server, a node server between us and the API servers. And when you run it once, it's going to check the real servers, it's going to copy the response in JSON, and for each extra run, it's going to serve those JSON instead of the real API response. And contract testing to make sure that the API does not change. So we, as the front-end application, are a consumer of the API. So we set up a test, a contract. We're saying, hey, from this response, we're expecting this to be a number. We need this key to be here all the time, and it's an array. We always expect this value here. And we take this contract, and the library is going to keep it in the pipeline. And when the backend runs any PR to try to change the API, it's going to verify that contract and see if something changed. And if it did, it's going to block the backend from merging completely. And when we want to run our end-to-end test in parallel, we make sure that instead of waiting for one test to finish in 12 minutes, all of them are running at the same time. So now you're not waiting for all the tests, you're just waiting for the longest test to complete. So it doesn't matter if you have one end-to-end test or 1,000, the time it's going to spend to run this is just going to be the longest end-to-end test that you have. And how we do this is you can use a parallelization orchestrator from Cypress or other libraries that's going to make sure that it's going to run this in CI machines. And what's amazing about it is if one of them fails, it's going to stop all of them completely. So you don't want to waste resources and time when you know already that the pipeline is broken. And we wanted to make the end-to-end test even faster. So how we did this is, for example, you have an application that goes from the home page to the catalog to the checkout page. And another end-to-end test that is from product page to another product page to checkout. And you can see that all of these have some intermittent steps like login or adding address. So you don't want to test the login functionality over and over again. You just want to test it once in a specific unit end-to-end test and then run it without it in your end-to-end test pipeline. And this is what we do. We implemented some flags in development mode. So if the URL has user logged in equals true, then we skip the login functionality completely. And we can simulate going to pages with the cookies already implemented. And that way we don't waste time on these intermittent steps that we have. So CSS and design matter, have checks in place like visual checks. Use component testing like a user in a real browser. Test results and not implementation. End-to-end tests are flaky, but they give you the most confidence. And don't duplicate tests for general functionality. Parallelizing tests in your CI/CD pipeline will give you the most speed and confidence of your end-to-end test. So testing web apps is easy, and I hope at the end of this talk, some of you may say this. So That's about it. About me, I am Nechudan. I'm a software engineer at Glovo. I like to write tech articles. I work on all 3 big frameworks and some small ones, and I have a cat and 1 Greek friend. So you can follow me at Nechudan on Twitter and Medium, and thank you.